Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss NTC MPL Physics Weekend Test 18. So let's start with question number 1. The electric lamp is connected to 220 volt 50 hertz supply. The peak value of the voltage is. So we know that Vrms is equal to V0 upon root 2. So peak value V0 will be root 2 times Vrms, which is 220 volt. So it will give you 311 volt, which is option 3. Next is question number 2. Voltage and current in an AC circuit are given by this and this value. Which of the following is correct? So you can see that current is leading and voltage is lagging. So what is the angle? So it is pi by 6 minus of minus pi by 6 over here. Phase difference will be this value minus this value, which is pi by 3. So current leads voltage by 60 degree, which is option 3. Question number 3. In an AC circuit, I is this, the time required for the current to achieve its peak value will be. So when the current will achieve its peak value, which is 100, so it is 100 is equals to 100 sine 200 pi t. So basically sine 200 pi t should be 1, and that is possible when angle is pi by 2. So over here time will be 1 upon 400 seconds, which is option 4. Question number 4. The peak value of an alternating EMF is 10 volt and its frequency is 50 hertz. At time t is equals to 1 by 600 second, the instantaneous EMF is. So it is E, which is 10 into cos omega is 2 pi f. So it is 2 pi into 50 into time is 1 upon 600, right? So it will be 10 cos pi by 6, which is 10 root 3 by 2, and that is equals to pi root 3 volt, which is option 2. Question number 5. A 120 volt AC source is connected across a pure inductor of inductance 0.70 Henry. If the frequency of the source is 60 Hertz, the current passing through the inductor is. So frequency of the source is given as 60 Hertz, and we have XL is equals to 2 pi FL. So this will be 2 pi F is 0.70 into L is F is 60 and L is 0.70. So this will give you the value of XL. So current I is V upon XL, which is 120 divided by 120 pi into 0.70. So it is 1 upon 0.70 pi, and that is equals to 0.455 ampere. Next is question number 6. The reactance of a coil when used in the domestic AC power supply is 220 volts, 50 cycles per second is 50 ohms. The inductance of the coil is nearly. So we need to find inductance of the coil, and reactance of the coil is given as 50 ohm. So 50 ohm over here is XL, that is equal to 2 pi FL. So L will be 50 divided by 2 pi into frequency, that is 50, right? So it is 1 upon 2 pi, and this is approximately 0.16 Henry. Question number 7. The graph given below depicts the dependence of two reactive impedances X1 and X2 on the frequency of the alternating EMF applied individually to them. We can say that, so XC is 1 upon 2 pi FC. So XC is inversely proportional to F. So when F increases, XC decreases, right? So first graph is corresponding to the capacitor, and XL is 2 pi FL. So it is directly proportional to F. So frequency increases, XL increases. So second graph is for inductor. So correct answer is option 3. Question number 8. A bulb and a capacitor are in series with an AC source. On increasing frequency, how will glow of the bulb change? So XC is 1 upon 2 pi FC. On increasing frequency, XC decreases, and because of that, current in the circuit will increase, and because of that, glow of the bulb will increase. So correct answer is option 2. Question number 9. In an LCR circuit, capacitance is changed from C to 2C. Okay. For the resonant frequency to remain unchanged, the inductive inductance should be changed from L to what value? So resonance frequency is 1 upon 2 pi under root LC, right? And it should be same as that of the, and 1 upon 2 pi, let's say new value is L dash and new value of C is 2C. Right, so this will cancel this will cancel this. So we have under root LC is equals to under root of L dash into 2C square on both the sides. So LC will be 2C L dash and L dash will be L by 2, which is option 3. Question number 10. Figure shows a series LCR circuit connected to the variable frequency source 220 volt and L is 5 Henry. Okay. C is 80 microfarad and R is 40 ohm. What is the source frequency which drives the circuit at resonance? So resonance frequency is 1 upon 2 pi under root of L into C, which is 80 into 10 power minus 6. So this will be 10 power 3 and this is 2 pi and this is 400. So this will be 1000 divided by 40 pi and this will give you correct answer as option 2. Question number 11. In an AC circuit, V and I are given by this value and this value. The power dissipated in the circuit is. So power dissipated in the circuit is V naught I naught divided by 2 into cos phi. Right. So V naught is 100. I naught is 1000 divided by 2 into cos phi. This is the phase difference. So this pi by 3, cos pi by 3 is 1 by 2. So this will be over here. This is in milliampere. So we'll have to multiply it by 10 power minus 3 also. So this will give you power as 25 watt, which is option 2. Question number 12. The primary winding of a transformer has 100 turns. So N1 is 100 and N2 is 200. The primary is connected to an AC supply. So V1 is 120 volt and the current flowing through it is 10 ampere. So I1 is 10 ampere. The voltage and the current in the secondary are. So V1 upon V2 is equal to N1 upon N2. Right. So over here, V2 will be V1 N2 divided by N1. V1 is 120, N2 is 200 divided by N1 is 100. Right. So this will be 2 and 240 volt is the current through the 240 volt is the potential voltage across the secondary. Right, now we know that N1 upon N2 is equal to I2 upon I1. Right, so I2 will be N1 upon N2 into I1. So it is 100 divided by 200 into I1 is 10. So it is 5 ampere. So correct answer is option 1. Question number 13. A step down transformer reduces the voltage of a transmission line from 2200 volt to 220 volt. The power delivered by it is, so P2 is 880 watt and its efficiency is 88%. So the input current is. So over here, efficiency is output divided by input power into 100, which is equal to 88. So input over here will be 1000 watt and that is equals to current input into voltage input, which is 2200, right? So I1 will be 1000 divided by 2200 and that is equals to 0.45 ampere. Question number 14. What is the RMS value of an alternating current when passed through a resistor produces heat which is thrice of that produced by a direct current of 2 amperes in the same resistor? So I square RMS into R is equal to 3 times 2 square into R. So this will be I square RMS is equal to 3 into 2 square. So RMS will be under root of 3 into 2 square, which is 2 root 3 ampere and that is equal to 3.46 ampere. Question number 15. An oscillator circuit consists of an inductance of 0.5 millihenry and capacitor 20 microfarad. The resonant frequency of the circuit is, so it is 1 upon 2 pi under root L into C. So it is 1 upon 2 pi under root L is 0.5 into 10 power minus 3 and C is 20 into 10 power minus 6. So after solving this one, you'll get option 3 Hertz. Question number 16. When frequency is greater than the resonant frequency in a series LCR circuit, it will be an inductive circuit. Yeah, because in that case, XL will be greater than XC. So, circuit will be inductive in nature, and in inductive circuit, voltage leads the current, right? So, yeah, both of these options are correct. So, option 1 is true. Question number 17. In an LCR circuit, 100 ohm is the resistor. When capacitance C is removed, current lags behind the voltage by pi by 3. So it is XL upon R, that is equals to 10 pi by 3, and XL will be R into 10 pi by 3, which is root 3. So this is 100 root 3 ohm. Similarly, when inductance L is removed, then XC upon R will be 10 pi by 3. So XC is again 100 root 3 ohm. So XL is equals to XC. That means circuit is in resonance. So impedance over here will be equal to resistance of the circuit, resistance in the circuit, that is equal to 100 ohm, which is option 2. Question number 18. An incident ray of light is falling on a plane mirror and getting reflected on a screen. If the mirror is now rotated with angular speed 20 radian per second by keeping the incident ray fixed, then at what angular speed the reflected ray would be rotating? So this is fact based question, bachcho, right? So in this case, reflected ray would be rotated by the double angle, right? So its angular speed will be double. So it will be 40 radian per second, right? So correct answer is option 4. Question number 19. We have a small object is placed 10 centimeter in front of a plane mirror. So this is object which is 10 centimeter. So its image will be 10 centimeter. 30 centimeter from the mirror, if you stand behind, look at this image. So that's you, and that is equal to 30 centimeter from the mirror. The distance focused for your eye will be, so it is 30 plus 10, that is 40 centimeter for image, right? So correct answer is option 3. Question number 20. An object is placed between the two plane mirrors inclined at an angle to each other. If the number of images formed is 7, the angle of inclination is. So number of images is 360 upon theta minus 1 over here, that is 7. So 360 upon theta is 8, and 360 upon 8 will be theta, which is equal to 45 degree. So correct answer is option 3. Question number 21. A ray is incident at an angle of 38 degree with the mirror. Okay, so this angle is 38 degree. This is I and this is R, and I is equal to R. The angle between the normal and reflected ray is, so this I will be 90 minus 38 degree, which is 52 degrees. So angle of reflection over here is equal to 52 degree, which is option 2. Question number 22. A beam of light incident on a plane mirror forms a real image. Okay. So the incident beam is, so for forming a real image, incident beam should be convergent in nature like this, so that there will be actual intersection of incident rays. So this is image. So correct answer is option 2. Question number 23. A man of length h requires a mirror to see his own complete image of length at least equal to. So mirror should be h by 2. Okay. So correct answer is option 3. Question number 24. A ray of light is incident on a plane mirror at an angle of 30 degree. The deviation produced by the mirror is, so it is 180 minus 2i. So this will be 180 minus 2 into 30, which is equal to 120 degree. So correct answer is option 4. Question number 25. Out of the following options, which one can be used to produce a propagating electromagnetic wave? So EM waves can be produced by accelerating charge, right? So correct answer is option 4. Question number 26. The Maxwell equation, closed integration of B dot dl is mu naught I plus epsilon d phi E by dt is a statement of. So this is modified Ampere's law, right? So correct answer is option 2. Question number 27. Displacement current goes through the gap between the plates of a capacitor when the charge of the capacitor changes, right? It increases or decreases. So correct answer is option 1. Question number 28. Electromagnetic wave is traveling along, velocity vector is along y direction, that is j cap, and e vector is along I cap. Then direction of b vector at that time is. So basically velocity direction is given by e cross b vector, right? So over here, when you do e cross b, it should be j cap. That means b vector over here should be along minus k cap, right? So correct answer is option 4. Question number 29. Body A of mass 4m moving with speed u collides with another body of mass 2m at rest. Okay, so this is A, 4m and u, and it is another body 2m. It is at rest. The collision is head-on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A is. So let's say after the collision, velocity of the colliding body is u1, which is m1 minus m2 divided by m1 plus m2 into, this is v1. So this is u1 plus 2 m2 u2 divided by m1 plus m2. So m1 is 4m, m2 is 2m divided by m1 plus m2, 6m into u1 is u, and this term will be 0 because initial velocity of the body 2 is 0, right? So this will be u by 3. So, initial kinetic energy of the body is half mu square and final kinetic energy of the body is half mu by 3 whole square, which is 1 by 9 half mu square. So if initial kinetic energy is k, then final kinetic energy over here is 1 by 9k. So fraction of energy lost is k minus 1 by 9k divided by k, that is 8 by 9, which is option 3. Question number 30. For any collision, momentum transfer takes place? Yes. In any collision, energy transfer takes place. This is not always true when in elastic collision, head-on elastic collision, when two equal masses are moving with the same speed towards each other, then there will be no energy transfer, right? So this statement is not always true. Third is impulsive forces are involved in collision. Yes. So only A and C are true, which is option 1. Question number 31. A system consists of two masses connected by a massless rod lies along x-axis. The distance of the center of mass from O is. So it is m1x1 plus m2x2 divided by m1 plus m2, which is 0.4 into 2 plus 0.6 into 7 divided by 0.4 plus 0.61. So this will be 5 meter, which is option 3. Question number 32. A circular ring of mass m is rotating about its own axis in the horizontal plane at an angular velocity omega. So initial angular momentum is I omega, which is m r square into omega, and if two point-sized body, each of mass small m, are gently placed to the rim of the ring at two ends of the diameter, then the angular velocity of the ring is. So in this case, angular momentum will be conserved. So initial angular momentum is equal to final angular momentum, which is m r square plus 2m r square into, let's say, new velocity is omega dash. So omega dash will be m omega divided by m plus 2m, which is option 1. Question number 33. We have three identical masses, each of mass 1 kilogram, are placed at the corners of an equilateral triangle of side L. Then the moment of inertia of the system about an axis along one side of the triangle is. So this is, let's say, this is the axis. This is m, and m, which is equal to 1 kilogram. So this is L, and L. So over here, if you take this angle, this is 60 degrees. So this length is L sine 60 degree, which is root 3 by 2 over here. So moment of inertia because of these two masses will be 0 because these two masses are on the axis, right? So only because of this mass there will be moment of inertia, which is mr square. So it is m into L root 3 by 2 whole square, which is ml square into 3 by 4. So m is 1, so it is 3 by 4 L square, which is option 3. Question number 34. A shaft rotating at 3000 rpm is transmitting a power of 3.14 kilowatt. The magnitude of the driving torque is in Newton. So over here, 3.14 into 10 power 3 is the power, which is tau into omega. So tau into omega, so over here omega is 2 pi into 3000 divided by 60. So this will cancel this and we have 50. So this is tau is 3.14 into 10 power 3 divided by 100 pi. So pi cancel. So we have 10 Newton into meter, which is option 2. Question number 35. When a hollow sphere is rolling without slipping on a rough horizontal surface, then the percentage of its total kinetic energy, which is translational, is. So this is hollow sphere. Its moment of inertia will be 2 by 3 mr square, and its translational kinetic energy is half mv square. Rotational is half I omega square, and omega can be written as v upon r. So this is v square upon r square. So this will be 1 by 3 mv square. So total will be translational plus rotational, which is half mv square plus 1 by 3 mv square, and that is equals to 5 upon 6 mv square. So percentage energy, which is translational, is half mv square divided by total, which is 5 by 6 mv square into 100, and that is equals to 60%. So correct answer is option 3. Question number 36. In a circuit, the current lags behind the voltage by phase difference of pi by 2. The circuit will contain which of the following? So current is lagging. So, and that 2 by pi by 2. So it should be what? Inductive circuit. So correct answer is option 2. Question number 37. An inductive coil has resistance 100 ohm when AC signal of frequency 1000 Hz is fed to the coil. The applied voltage leads the current by 45 degree. What is the inductance of the coil? So applied voltage leads the current by 45 degree. So over here we have resistance of 100 ohm. So XL divided by R should be 1045, which is equal to 1. So XL should be R, which is 100. But XL is 2 pi FL, which is 100. So L will be 100 divided by 2 pi into F, which is 1 upon 20 pi, and it should be 16 millihenry. Question number 38. In the circuit shown below, what will be the reading of the voltmeter V3 and ammeter A? So over here you can see that potential difference across inductance and capacitance same. So circuit is in resonance, right? So effective impedance is equals to resistance. So over here current will be I is equals to V upon R, that is equals to 220 divided by 100, that is 2.2 ampere, and the potential difference across V3 will be 220 volt, because this will be the drop over here, right? So correct answer is option 3. Question number 39. In a series resonant LCR circuit, the voltage across R is 100 volt, R is 1 kilo ohm, and C is 2 microfarad. The resonant frequency is 200 radian per second. At resonance, voltage across L will be. So over here, resonance frequency is 200 radian per second, which is omega is 1 upon under root LC. But in resonance, the potential difference across capacitor is equal to potential difference across inductance, right? So potential difference across capacitor is equal to VC is equals to VL, and that is equals to I into XC. I into XC, right? So XC is 1 upon omega C, right? So this is the value of potential difference across L. Okay, now let's find the current. So current over here will be V upon R, that is because total potential drop will be across resistance, and resistance will be effective impedance. So current will be 0.1 ampere. So this is 0.1 divided by 200 into C is 2 into 10 power minus 6. So this is 10 power 5 divided by 200 into 2, and that is equals to 250 volt. Question number 40. The potential differences across the resistance, capacitance and inductance are this much. Power factor of the circuit is. So power factor cos phi is R upon Z, which is VR upon under root of VR square plus VL minus VC whole square. So VR is 80 divided by under root of VR, which is 80 square plus 100 minus 40 whole square, that is 60 square. So this will be 80 divided by 100, that is 0.8. Question number 41. RMS voltage is 110 volt is applied across a series circuit having resistance and impedance. The power consumed is. So power consumed will be V square RMS divided by Z into cos phi. Right. So V square RMS is 110 divided by Z. So Z over here is 22 into cos phi is R upon Z, which is 11 divided by 22. So this will be 2, and it will be 110 into 110 divided by 2 into 22. So this will be 2, and this will be over here, this will be 10, right? So we have 1100 divided by 4, which is 275 watt. Next is question number 42. In a transformer, the number of turns in the primary and secondary are 1000 and 3000 respectively. If the primary is connected across 80 volt AC, the potential difference across each turn of the secondary will be. So V2 is N2 upon N1 into V1. So this is 3000 divided by 1000 into V1 is 80. So over here it will be 240 volt. So potential difference across each turn of the secondary will be V2 divided by number of turns, that is N2, that is 240 divided by 3000, and that is equal to 0.08 volt. Question number 43. A capacitor, a resistor and an inductor are joined in series with an AC source. As the frequency of the source is slightly increased from a very low value, the reactance. So reactance over here, like XL is 2 pi FL and XC is 1 upon 2 pi FC. So when you increase the frequency, XC decreases and XL increases, right? So reactance of the inductor will increase. Question number 44. A particle is moving along x-axis with 4 meters per second in front of a plane mirror, which is moving along negative direction with 2 meters per second. Okay, so this is particle 4 meters per second, and the mirror is moving like this with 2 meters per second, and this will be the object. Speed of image with respect to ground is, okay, right. So speed of image with respect to ground is speed of image, you can write it as speed of image with respect to mirror is speed of image minus speed of mirror with respect to ground. Okay. So over here, let's find the speed of image first. So speed of image with respect to mirror is what? If you look at it, it should be 4 minus of minus 2, that is 6 meters per second, but 2 in the negative direction. So this will be minus 6 is equals to speed of image minus of speed of mirror, which is minus 2. So minus 6 is equals to Vi plus 2, and Vi will be minus 8 meters per second. So over here, it should be option 3. Next question is question number 45. A watch shows time as 3:25. When seen through a mirror, time appearing will be. So it will be 1160 minus given time, there is 3:25. So this will be 5, 3, and this will be 8. So 8:35 will be the time seen through the mirror, which is option 1. Question number 46. Instantaneous displacement current of 1 ampere in the space between the parallel plates of 1 microfarad capacitor can be established by changing potential difference of. So over here, potential difference, basically Q by T will be what? Q is equals to CV, so CV by T, and that is equals to IT. So V by T, that is rate of change of potential difference, will be V IT upon C, and IT is 1 divided by C is 10 power minus 6, so it is 10 power 6 volt per second, which is option 2. Next is question number 47. A parallel plate capacitor consists of 2 circular plates, each of radius this, separated by distance of this, If the voltage across the plates is varying at the rate of this, then the value of displacement current will be. So Q is equals to CV and Q upon T over here, which is CV by T, and that is equals to what? ID. So ID will be CV, which is epsilon naught A upon D into V by T. So epsilon naught is 8.85 into 10 power minus 12. A is pi r square. So pi into 0.02 whole square divided by D, that is 0.1 into 10 power minus 3 into V by D is 5 into 10 power 13. So after solving this one, you'll get the value as option 3, that is 5.56 into 10 power 3 ampere. Question number 48. A body of mass 1 kilogram is moving with velocity 10 meter per second, collides inelastically head-on with another body of mass 2 kilogram moving in the same direction. Let's say this is Q2. After the collision, the first body continues to move in the same direction with 6 meter per second. If E is 1 by 2, find the velocity of center of mass of two bodies. So coefficient of restitution, let's say this after collision, velocity of second mass is V2. So it is velocity of separation, that is V2 minus 6 divided by velocity of approach, that is 10 minus U2. So 10 minus U2 is 2V2 minus 12, right? Now conserve the momentum. So 10 plus 2U2 is equal to 6 plus 2V2. So over here, you can write 5 plus U2 is equals to 3 plus V2. Right, so U2 will be V2 minus 2. Put it here. So this will be 10 minus V2 plus 2 is equal to 2V2 minus 12. So we have 24 is equal to 3V2. So V2 will be 8 meter per second. So velocity of center of mass will be m1v1 plus m2v2 divided by m1 plus m2. So m1 is 1, 6 plus m2 is 2 into v2 is 8 divided by m1 plus m2, that is 3. So it will be 16 plus 6, that is 22 divided by 3, and that is equal to 7.33 meter per second. Question number 49. F vector is given, R vector is given, and the value of A for which the angular momentum is conserved. So for conservation of angular momentum, torque should be 0. So torque is R cross F. So it is I, J, K, positive, negative, positive. R is 2 minus 6 minus 12, and it is A, 3, 6. So it is I cap. This is minus 36 plus 36 minus J cap, that is 12 plus 12A plus K cap. So it will be 6 plus 6A, and it should be 0 I cap plus 0 J cap plus 0 K cap, right? So if you put the coefficient of J or K is equals to 0, you'll get your answer. So it is A is equals to minus 1. Next is question number 50. A rod PQ of mass M and length L is hinged at end P. The rod is kept horizontal by massless string tied to the point Q as shown in the figure. When the string is cut, the initial angular acceleration of the rod is. So when the string is cut, this mg will rotate this about to point P. So torque produced by mg will be mg L by 2, and that is equals to I into alpha, right? So I about this point of the rod is ml square by 3 into alpha. M cancel, LL cancel. So alpha will be 3G upon 2L, which is option 1. So that is it for today's session, guys. I'll see you again with the next paper discussion. All the best, everyone.